This short video is about processing a kinematic survey in Carlson SurveyGNSS. Just about the terminology. Kinematic survey is a survey where I want to have a result, a position for every GPS observation. So if my observation rate is 1 observation per second, I want to have a solution result for every second. If you compare that to stop and go, for stop and go I just want to have a solution for the point numbers that I entered. So stop and go is sometimes called semi-kinematic, but this is true kinematic, you could say. So that's just to talk a little bit about the terminology. This is SurveyGNSS, and I will just create a new project like this. Just give it a name, kinematic, and open it, and then I'll import my data. This is my base station, so I will just drag and drop my my base station, and also import my trajectory, so my rover information. I'll do that a little bit differently. We'll just say open, and then in this case I'm using a septentrial file. So that's a specific Altis septentrial format. Let's see, we can use this one. I'll just open it, and then as you can see here, it's a lot of data because we need every second. So takes a little bit time to import the data. So there we are. As you can see now, we don't have specific point numbers, but we just have seconds. So this is time, this is date and time in seconds, 27, 28, 29. Then going to the map view, we'll say zoom extend, and we'll be able to see what kind of a survey we have. And as you can see, it's looks like data from a ship, from a vessel that was going along this river, and this is the base station. So we'll process the data. We will select the base as our known station, like this, and we go to observations, and we will again select the base station. So with control click, this is our base station, and then we'll just select the first point of the trajectory like this, and we go to compute. Then the computation is started. Again, this is a reasonable amount of data, so depending on the processing power of your laptop, this could take some time. So it says ready, so there we are. So we go to our vectors, and here's our result. Again, here is the point information. So we're talking about seconds rather than point IDs. And as you can see, we have a fixed solution for every second, also with a pretty good accuracy. So this is the accuracy in centimeters, so that's all well, except for the height, but it's around a centimeter. So that is a decent result. Then about the export, and the question is what is the export format for this data. So if you go to preferences and you go to vectors, then there is a setting for the kinematic file format. So you could use, as we did in this case, geographic and date and time, but there are some other options as well. You can also use the GPS week or the GPS seconds, and you could also use an Earth-centered, Earth-fixed format. So typically kinematic files are used, like we saw in this example, on board of vessels, of ships, and then the GPS result is combined with other sensors. And you can really, by making a selection here, find a suitable format that you can then use in other software. So looking at our file now looks like this. It's a position file with the extension POS, and as you can see, date, time, latitude and longitude in decimal format, and then the height and the solution, including the accuracy. Okay, that's it for this this presentation. I hope it showed how easy it is to do your processing of kinematic surveys. Thank you.